guys, in this video what we're going to do is we're going to look at what the graphs of sine theta, cosine theta and tan theta look like, okay? And one way of always knowing what a graph looks like is to make a table of values and then plot those points on an axis, okay? So with sine theta, I've already done a lot of the work for you because I've put values of theta, so I've gone 0, 30, 60, 90, 120, so on and so forth, so in multiples of 30. And then I've found out what the values of sine theta are for those angles. And remember, these are all angles you should actually know, because 30, 60 come from those special triangles. So you should know, without any aid of a calculator, that sine 30 is equal to a half. You should also know that sine 60 is equal to root 3 over 2. I can't tell you how frustrated I get with year after year, student after student, not bothering to learn those facts, okay? Sine 30 is a half, sine 60 is root 3 over 2, okay? And you can check the others with your calculator. You know, put sine 90 into your calculator, it'll give you an answer of 1, okay? Put sine 120 in, and it will give you exactly the same answer as sine 60. So actually sine 60 is equal to sine 120. They're both root 3 over 2. It's also true that sine 30 is equal to sine 150. You can check them with a calculator. They're both a half. Put sine 150 into your calculator and you'll get half. And you can actually put all these values into a calculator, and what you can see there is what you're going to get. Okay, so I'm now going to plot this. Okay, so you'll see that the maximum value of y I get is 1, and the minimum value of y I get is minus 1. Okay, so I'm just going to put 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360. Now, what's sine 30? Sine 30 is a half. Okay, so if x is 30, y is a half. Okay, or if theta is 30, y is a half. What about 60? Well, that's root 3 over 2. Just using a calculator, root 3 divided by 2 is equal to about 0.866. So maybe somewhere like here. Okay, sine of 90 is 1, and sine 120 is the same as sine 60. You can see what's happening. Sine of 180 is 0. Sine of 210 is minus a half. Okay, sine of 240 minus 0.866. Sine of 270 is minus 1. Okay, sine of 300 is the same as sine of 240. Sine of 330, the same as sine of 210. And so this is what we're getting. Okay, we're getting a shape that looks like this. Okay? So that's what your sine curve actually will look like. And I expect you to remember it. I expect you to remember this information. I'm going to draw it again in a rough way. Okay? So the sine of your y of sine x looks like this. Okay, so that will be 90, 180, 270, 360. You should know that it looks like that. And it will actually carry on forever. You can actually go for angles that are bigger than 360 or even smaller. It will just carry on in that pattern. Okay, so that would be 450, 540, 630, 720. The pattern will continue. Okay, so that's what sine will look like. I encourage you to stop the video and have a go and see if you can see what cosine will look like and what tan will look like. Okay, cosine is easy, tan is not easy. Okay, stop your video and have a go. Okay, hopefully you've done that. So you do cosine of 0 is actually equal to 1. That's actually equal to 1. Cosine of 30, you should know, is root 3 over 2. Okay. Cosine of 60, you should know, is a half. Cosine of 90 is 0. Okay. Cosine of 120, put that in your calculator. Cosine of 120, and you get minus a half. You'll spot some patterns here. Minus root 3 over 2, minus 1. Minus root 3 over 2, minus a half, 0, a half, root 3 over 2, 1. Okay, so plotting it, you'll see it's actually very, very similar to the sine curve, but with a slight difference. Okay, it'll actually look like this. Okay, this is what your cosine curve will look like, and the numbers here will be, this will be 90, this will be 180, this will be 270, this will be 360. So it's very similar to the sine curve. The sine curve is just sort of a little bit behind the cosine curve. Okay, they're very similar, but one is following the other. Okay. Now, tan is actually a little bit more difficult to do. Tan of 0 is 0, okay? Tan of 30, 1 over root 3. Tan of 60 is root 3. Now, tan of 90 actually, there's no number that's tan of 90. Let's just think about why. Let's say we have a right-angled triangle here. And let's say this angle, so this is the opposite, this is the adjacent, this is my angle. Well, actually, if this angle is in fact 90 degrees, well then it's not a triangle. So it's not possible to have a tan of 90. Okay? So we say that is undefined. There is no such value as tan of 90. Okay? Tan of 120 we can do. Let's just put that in my calculator. Tan of 120 is negative root 3. Tan of 150, negative 1 over root 3. Tan of 180, I think we'll find is 0. Okay, tan of 210, just using a calculator, is 1 over root 3. So the pattern will start again, root 3. Tan of 270, put that in your calculator. Tan of 270, your calculator will say math error. That's because it's not allowed. Okay, this is undefined. Okay, then minus root 3, minus 1 over root 3, and back to 0. Okay, so now what is this going to look like? I've got to be really, really careful with this one. So tan of 0, let's put the numbers in. So we're going to go, 0, 30, 60, 90, 120, 150, 180. I'm going to make a bit of space here so it's clear. 210, 240, 270, 300, 330. That's probably as far as I can go. I'm running out of space. Okay. So tan of 0 is 0. Okay. Tan of 30, 1 over root 3. Let's just change that into a decimal. 1 over root 3 is about just a little bit more than a half. So let's make this be 1 minus 1 here. Okay, so we're going to end up with just a little bit more than a half. Tan of 60 is root 3. Root 3 is equal to 1.73. So that's maybe somewhere like this. But tan 90 is actually undefined. So you actually can't plot any value for tan 90. And actually you can't plot any value for tan 270 either. Tan 120 is going to be, say, somewhere down here, minus 1.7. Tan of 150 is going to be, say, somewhere like this. Tan of 180, 0. You can see what's happening. Okay, and then we're getting down here again. Okay, now, so when we put all of this together, what it actually looks like is this. It does this. Tan will get bigger and bigger and bigger up to 90. And then it can't be 90, and when it appears the other side of 90, it will be really, really small. Okay, really, really negative, and it will be the same over here, and it will appear down here till it gets back to 0 at 360. Okay? Now these lines, they have a name, and you need to know the name of these lines. They're lines that can't be touched by the curve. They have no value at that point. These are called asymptotes. Asymptotes. So we have asymptotes on the tan curve. Okay? Please learn what that word is and what that means. It will become more and more important as we move through the course. Okay? Right, so this was your sine curve. Y equals sine of your angle. Okay, it looks like that. This is your cosine curve. Y is equal to cosine of your angle. And this is your tan of your angle, and I've done them all between 0 and 720 degrees. But they actually carry on forever and ever in both a positive and a negative direction. Okay? Now, why does any of this matter? It says use your graph of y equals sine x and your calculator to solve these equations for between 0 and 720. Okay? Give your answers correct to the nearest degree. Now, the reason why this matters is sine x equals 0 actually has more than one answer. So let's go, x is equal to sine minus 1 of 0. Now you can put that into your calculator. And you should know that the inverse sine of 0 is 0. Okay? Now let's just have a look at the sine curve. Well, that's what you're getting there. Okay, sine of 0 is equal to 0. But it's not the only place where it equals to 0 within the range that you've been asked to do. It's also here, 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 and here. So in this question, you are specifically asked for this range, 0 to 720. So there are actually 4 answers. 0, 180 degrees. What else? Let's just have a look. 180, 360, 360 degrees, 540 degrees, and 720 degrees. Now, there are actually infinitely many answers, but there are only 4 answers within this domain, this set of data. Okay, so I hope that makes sense. What about sine x equals 0.3? So again, we'll use a calculator. X is equal to inverse sine of 0.3. So shift sine 0.3 equals 17.5 degrees to 1 decimal place. So let's have a look at that. Sine of 0.3. So where's 0.3? I would say it's probably somewhere about here. 0.3 is there. So this number here, that's where you're getting your 17.5 degrees from. Okay? But that's not the only answer in this range. There's actually 4 answers in the range from 0 to 720. Okay? One here, which you already said is 17.5. One here, and one here. Now, how are you going to find out what this value, and this value are? What you're going to do is you're going to understand that the sine curve has symmetry. So if this distance is 17.5, then so is this distance. So another answer is 180 minus 17.5. Okay, so calculator 180 minus 17.5 is equal to 162.5 degrees. we also know that this distance is 17.5, so this value here is going to be 360 plus 17.5, so that's 377.5 degrees. And then this distance here is also 17.5, so that's 540 minus 17.5 degrees, so 540 minus 17.5 equals 522.5 degrees. So there are my 4 answers. So this equation didn't just have one answer. It had 4 answers within the correct range, within this range. Okay? For values of my angle between 0 and 720 degrees. I hope that makes sense. Okay? Let's just do a couple more examples. Let's do cosine. Let's do this one. Not going to do all of them. We're going to do that. Let's do this one. So cosine of x is equal to minus 0.5. Now again, use your calculator. Do shift cosine of minus 0.5. So shift cosine negative 0.5. And your calculator will tell you that that is 120 degrees. Okay? Now, is that the only answer? Let's have a look. Let's go to your cosine curve this time. Go for minus a half, that's there. And you see there is more than one. In fact, there's 4 again, 4 solutions within that range before we stop at 720. So there's one there, there's one there, there's one there, and there's one there. So one of the angles is 120. We already know that. Okay? We can read off the others or use the symmetry of the curve. Okay? For example, we know that this distance here is 120. Well, that means this distance here is 120. So 360 minus 120 is 240. Okay, we can also work out this should be 360 plus 120. So another angle is 480 degrees. And then 720 minus 120 is equal to 600. So there is your other answer. 4 answers within that range. Okay. The number of answers depends on how big you're making your range, and the question will tell you that. It can change from question to question. Right, let's do another one. We'll do one more. Let's do a tan. Let's go for tan x equals 3. So again, use your calculator. X equals tan to the minus 1 of 3. So shift tan of 3, and that is 71.6 degrees to 1 decimal place. Is that the only answer? No, it's not. Here's tan. So actually what we don't have here is minus 3. So I'm just going to extend things out a little bit here. So let's just say that comes down like that. Okay, and then this comes down to minus 3 here. Okay, so minus 3, so we've got slight problem. Oh, sorry, it's not minus 3, is it? It's positive 3. Sorry, bear with me, guys. Let's just delete that. I thought that things looked a bit weird. Okay, let's just delete that. And what I'm going to do is just move this down a bit. Okay, instead, actually, what we need to do is go up. Say 3. Okay, and let's read off from 3. Okay, so I've actually got 4 answers again. One of them, well, that's where I'm getting my, what was it again? 71.6. There's 71.6 degrees. So here are my other 3 answers. Well, what are those other 3 answers? Notice that these sections of the tan curve, so like here to here, to here, to here, to here, you're always adding 180 each time. 0 to 180 to 360 to 540 to 720, always adding 180. And so that's the same here, from here to here to here to here, always just keep adding 180. So that's one of my answers there. Another answer is going to be add 180, 251.6 degrees, add another 180, 431.6 degrees, and add another 180, 611.6 degrees, before we then suddenly go outside of the range that the question was interested in. Okay, so 4 answers there. Okay, so I hope that makes sense. So sometimes with cosine, sine, tan, there's more than one answer. And just put that into a real life context. Let's think about that ambiguous case. I taught you about a situation with an ambiguous case. Okay, let's just do some deleting. Sorry, 1 second. Let's just delete all of this. Now remember, what we had was we had a triangle that looked like this. Let's say this was 10, this was, I don't know, 5, and this angle is what we wanted, this angle was equal to 30 degrees. What we wanted to know was what this angle is. Okay, so let's just get rid of theta from that. Remember, this was the ambiguous case, so this angle was 30 degrees. And you said, okay, we can use the sine rule. So we could say that sine of your angle over 10 is equal to the sine of 30 over 5. So the sine of your angle is equal to 10 times sine 30 over 5. And so theta is equal to inverse sine of 10 times sine 30. Actually, I think I've picked a duff question here. Let's make that 6. Does that work? 10 times over here. No, it won't. Yes, it will. Yes, it will. So that's over 6. That'll work. Okay. So we end up with this answer. Shift sine of 10 times sine 30 divided by 6. Okay, and we get an angle of 56.4 degrees to 1 decimal place. Okay, but remember, we didn't know whether we meant for it to be like this, an acute angle, or like this for an obtuse angle. Well, let's look at the sine curve. Sine curve looks like this: 0, 90, 180, 270, 360, and then 1 minus 1. I just know it. Okay, it looks like this. Oh, sorry, that's badly drawn. Let me fix that. Very badly drawn. If you make a hash of it, start again. Okay. And then like that. Okay. So what we're saying is that we've got an acute angle of 56.4. So let's say somewhere like this, okay? Or rather, we know what this is equal to. Let's just actually work that out. 10 times sine 30 divided by 6 equals 0.83 recurring. So we're doing theta is equal to sine to the minus 1 of 0.83 recurring. Now, we don't know whether it's an acute or an obtuse angle, so we can assume it could be both. And we're seeing that it could be both. Okay, because we've got two angles there. Okay, one of them is your 56.4, and the other one is 180 minus 56.4. So you're understanding why that is the case, both from the graph, and remember in the lesson I taught you how you can find it basically using isosceles triangles. So all pins together and make sense. Okay, so any problem